with them if they are okay with that.
Either way, it's 2:30, so we got to kind of get going.
Yeah, we'll figure it. If I can ask.
Hi, Mike.
Hey, can you hear us?
Yeah, it's Bill Atwood.
Can you hear me?
I can hear you well.
Excellent. Welcome. Good to see your face.
Yep. I'll be downtown later in the week, but I can't make it today. So I'm remote.
All right, we're going to get started. We got a completely full agenda. You got the clicker and you got the microphone.
Okay. Let's see. I'll bring them up here as well. Okay. So I'll start. Yeah. Well, welcome to PIM working group. Good to see a lot of people here this time. It's a small room, so it looks fuller. Let's go to the note well, maybe. I got the, all right, you gave me the clicker. So there's a new note well this time. Maybe you already seen it earlier today. I think it's more or less the same content, but at least it's a new slide. So you're all supposed to know about this when you participate in the IETF. And this is our agenda. Any comments on this? Does it look okay? So for the two first presentations, we'll kind of do them together and then have some joint discussion afterwards. We hope to make some progress on these two DR drafts and see where the working group wants to go. Yeah, Torres?
Yeah, this quick agenda bashing point.
McGill, and it's 11 a.m. to 12:30 side meeting, and it's on the side meeting board.
All right, yeah, let's get started. We'll try to be quick with some of these things here. So for the agenda, yeah, we'll have some discussion on these DR drafts. Maybe we'll cut a little shorter than we planned. And yeah, unless there's any comments, we'll just move on and save some time here. For working group status. Okay, yeah, just quickly. So we have the 11th fall biz. We just did a working group last call on that. Troy's make some big changes. He'll talk about that later. We'll decide what to do. We got these two DR drafts we'll discuss shortly after this. And then we have some drafts, like 3 drafts in RFC editor's queue here, and a couple of drafts we are not discussing, and lessons learned we are discussing. Yeah, just trying to be a bit quick here. And we have all these address allocation related or address assignment related drafts. So 2 of them requested publication, 1 just finished last call, and we'll move forward with all of these drafts. And then the IGMP MLD proxy PFM enhancements are being discussed today, and ECMP we are not discussing today. So that's it for the working group status. So then I think we'll go to the first slot, Sandy, DR improvement. Oh, do you want to use this?
Good afternoon. I'm Sunny Zhang from ZTE. This presentation is for old draft PIM-DR improvement. And I present this draft on behalf of our co-author. And this is old problem in the internet. So we know that fast changing of DR takes time to coverage and causes packet lost. So it takes effect on modern services such as IPTV, net meeting, etc. So in the left figure, you can see if the existing DR fails in the network, and the packet will lost until the new DR is elected. So it takes time. And in the right figure, there is existed DR in the network, but when there is a newcomer coming to the network with higher priority, the newcomer will take the DR role, and the DR will be replaced, and the existing DR will stop to forward the packet, and the newcomer will take time to build the multicast tree from the source. So it takes time, and it's still packet loss here. Yeah. So we'd like to introduce a new BDR, and we'd like to make the DR as a sticky role. So that is, the DR will not be changed once elected. So unless it fails, obviously. So even if a new devices with a higher priority join the network, the existing DR's role will not be changed. And we introduce a new BDR role. So the new BDR role will follow the DR election algorithm. So once it's elected, it will monitor the DR's situation. When DR fails, it will take over the DR's responsibility when the BR fail in the web. So before it takes the role of DR, it will also join the multicast tree like the DR. So, but it will not forward the traffic unless the DR fails. So this is the solution introduction. So we defined 2 new options in hello message. One is DR option, and the other one is BDR option. So when a new router comes into the network, it only sends a hello message with DR and BDR option set to 0. But we know that we have already the existed priority field in the message, so it will be set to the normal value as usual. So when one hello hold time expires, the new router will receive the hello message from other routers. So he will know, oh, there is or they are already. So the new router will not let himself to be the DR, even if it has a higher priority. So but we know that the BDR will be elected according to the algorithm defined in FC 7761. So the BDR will be the highest priority or the second highest priority in the network. So this idea is borrowed from OSPF DR election as defined in FC 2328, section 9.4. So except that for BDR election, in OSPF, the DR and BDR will both will not be changed according to the definition in FC, OSPF FC. But in our algorithm, the BDR will be the highest or the second highest priority on the LAN. So the advantages of our solution is that there is explicit signaling. So we if we use because we use explicit signaling. So if somebody cannot support this function, we can easy to find it. So we can avoid error handling. So especially if when there is devices that do not support this function in the network, and obviously it's a sticky solution. So there is no DR oscillations. So that could cause flow interruptions or flow rate fluctuations. So, and the compatibility of this solution is all routers in the LAN need to support the signaling. But if somebody will not support it, we can fall back to use the function defined in FC 7761. Yeah. So that's all the solutions. So,
Yeah, so just Yaman, come, yeah, please come up. So yeah, just a brief background. So we basically have two working group drafts that deal with DR election and backup DR and sticky DR. So the idea here is that Mankamna will present his alternative, and then we can have some discussion to see what the working group thinks we should do.
Okay, good afternoon. So I'm going to, I think maybe I don't need to really restate the problem statement because problem state remains same what Sandy was talking about. Just to give a brief history that when we started working, initial solution what C presented using hello option is what we proposed in PIM working group. And after giving some more thoughts that is it really needed to have extra state machine there, or do we have enough information already to select backup DR? And that's what this solution talks about is where if you look at this picture in the right hand side, if I have such routers from R1 to R3, consider that R4 is not here yet. And if R1 to R3 is present, can I just do DR and backup DR election based on the information available already? So do I really need some extra hello options there before I can run my backup DR? So this draft talks about that instead of having extra hello options, why not to just reuse the existing mechanism? And the only changes is backup DR does make upstream tree and it will not be forwarding traffic on the LAN. So the only difference I would say between these two draft is whether we want to carry some extra information about backup DR versus do we want to have just backup DR election based on the initial hello exchange itself. That is the gist of this draft. Last time I had presented, so I just don't want to go in all the slides, and considering we already lost first 20 minutes, I would rather be happy to see if there are any questions, comments from working group.
So just one question. So you talked about backup DR, but there's also a sticky part?
Yes,
Yes,
so
or-
stickiness, we moved it out in the different draft because there was a comment from working group that backup DR, having functionality of backup DR and having stickiness, both are kind of independent. They are not really related to each other. And last time when I was talking about stickiness behavior, I did go through the documentation from HP implementation and Nokia implementation as well, where the stickiness behavior is using what is defined in the other draft, where when you're doing DR election and if you really want to have a stickiness behavior, so by the way, it is implementation with Cisco as well, that no matter what is the DR priority configured, once you want to be in stickiness behavior, you always give yourself a max DR priority. So that makes sure that no matter who is coming in the network will never get the DR priority assigned. So that's the other part which was forked into a new draft. So I think now, right now, the question is we have around three different options, and how do how do we want to make it a single solution? Yeah, Peter.
Peter from Cisco. So I just have a question on that solution that you mentioned to indicate the max priority. What if a couple of routers are indicating max priority? Which one do you pick?
So, so what we do, your initial DR election will happen based on initial procedure. So for example, if you look at this picture, priority is 100, 200, and 300. So the first election will happen based on the configured
Understood.
priority.
Yeah.
After that, it is kind of a mutex. So once you have become DR, you start announcing the max DR priority.
Yeah, but what prevents other routers doing the same? Do you prevent anyone to advertise the max?
It could be bug, but
Well, yeah.
yeah,
Be careful because I've got some experience with
sure.
this part.
So Makamada, what are the three options? I know that there's what Sandy mentioned, which was, introducing a new hello option for a new DR. Um,
Not
and
three options, so it's three drafts. So one is the
oh,
stickiness,
three
which is
drafts. I
yeah,
see. Okay. And then the one you just described is an
yes,
actual new BDR
yeah.
with no new hello options. We've adopted both in this working group. We thought they're both a good idea. We just need to now decide,
How do you want to make progress? Yes.
do we combine them? Do we keep them separate? Yeah. And Sandy's mentioned it before that she sees potential problem with technical issues with BDR.
Right. So also, do we choose one of them, or do you think it's useful to have both solutions? Or yeah.
So in my opinion, if we have two solutions about it, one is sticky and the other one is non-sticky, I think it's reasonable, just from my personal perspective. But if we have two sticky solutions, we may have to figure out which one is the best, and we can choose only one. Yes.
So
So
stickiness behavior and DR election, to me, both looks orthogonal because it really depends on deployment to deployment. One deployment may go ahead with stickiness behavior with just DR, may not do backup DR. Or some deployment may choose to have just backup DR, not stickiness. So it really depends on different use cases. I don't think as a protocol we can really enforce that you do DR, BDR, and stickiness all three all the time. It would be more of operators choice that how they want their network to behave in different failure scenarios.
okay. According to my experience on the existing implementation, we think that there are our solution, the PIM in PIM DR improvement has been deployed in our network, and it has some experience. And the other one I think is the max priority solution from HPE. Yes, I think it's also being implemented and has been deployed. So I'd like to know if there is any other existed has been deployed solutions for it, and we can discuss them together, and we can figure out which one is the best one. Yeah.
Yeah, with Stig here. Yeah, with as yeah, just speaking as an individual participant. I do feel like, in my mind, number one thing is to find a sticky DR solution. Well, one or two sticky DR solutions. But once we have a sticky DR solution, then we can think about how can we do backup DR, and you can do that with either sticky solution.
Okay. So if we agree that we can use the sticky DR, but about the BDR, we can consider if we have other option for it. It's reasonable. We can discuss it together. Yes.
That's all. Yeah, we'll have to sit down once.
Okay.
Yeah, I guess one more thing though is there could be deployments that don't really care about the stickiness, but they still want to have a backup DR.
Yes. Yes.
Yeah.
Yep.
Thank you. We're back on time.
Yeah, I would say otherwise it's too quiet on our mailing list, so it's great if we're able to have some discussion there between meetings. Okay, Mike is
Okay,
next.
so all these authors are here, which is great. We've been making slow but steady progress on this draft. This is the one that we just added based upon comments from David. Can't remember his last name. He provides some good, what's that? That's it, yep. And that is the RPT to SPT switch over based upon threshold. So that's what we added. And this is just the actual text that we added. Just talking about the many, you're familiar with this in your own implementations where you're able to configure a bandwidth or packet rate that triggers the switch from the shared tree to the source tree, which again is based upon a certain threshold that you define. It was designed to give operators greater control over that switch over and when to build source trees for high bandwidth flows. There are challenges with that. I'm remembering this from long ago when we had that, I think back when Turles and I worked together, we had this capability. And I do remember there were some challenges with that. You know, the state machinery required to trigger this and across different implementations, being able to make sure that that was consistent. And the truth of it, it seems, and this is why we're bringing it to you, just to see if this is true. If you've seen any other, if you're seeing it used today, and if you see any of our statements not being correct, but many operators do seem to find that the default behavior of immediate switchover to the SPT tree is sufficient for their needs. And most networks either switch that mechanism to 0 or infinity, you know, either immediate switchover or never switchover. So I guess this being that this is a lesson learned draft, the lesson learned is sometimes we add complexity where maybe we don't need to. And this may be one of those cases, even though we thought it would be beneficial to operators. And that again, may have been unnecessary. Any comments about this thing that we just added?
Hi, this is Dino. Something just came to my mind. So people like shortest paths, and that's why the default was always the switch over. But people like less state, so they wanted RP trees. So to be able to get that happy middle thing, I've known that there's been deployments where you put the RP on the first hop LAN. So you have star comma G state everywhere, but since the sources are concentrated in one area of the data center, you have a shared tree, but it looks like a shortest path as well. I don't know if we should put that in there.
Yeah, good point. Yeah, that's a good point. We should probably put that in there. Thank you. Anything else?
I guess the challenge with that is if the goal is to reduce state, you have to have all that state in all of those RPs, even if they don't need it, because you need MSDP to carry that state. Otherwise, how would they know that? So I think
Not interdomain, it's all controlled. The state goes in a big router on the first hop LAN. That's the way.
yeah. Yeah. So I don't know. To me, the lesson I learned was we cared about state at one point in time because memory was expensive and scarce. And then over time, memory got cheap. And so state was less of an issue. And I think we actually have this in the draft elsewhere. But I think one of the big lessons is kind of premature optimization, that we were so worried about state. I think Dave Meyer made this great statement like 15 years ago. we were so worried about a state problem, we solved the state problem by making it so complex that nobody would ever use it. So,
Yeah.
so if you don't deploy this, then there's never a state problem.
Yeah.
So
We have, it's in the draft. That's very statements in the draft. Yeah.
I want to add too that our assumption that the problem with state was in memory capacity, and at the time that was an issue, and we silently let state grow in other ways where capacity wasn't the problem, it was the transition, it was convergence time. So the state impact was not memory, it was the performance of the network under failure.
And could I add to that FIB management, FIB downloading the FIB and RPF?
Yes, it's part of the game, right? Once
All
you
that stuff.
right, triggering and managing and pushing it down.
Should we include all those details?
Probably so.
Also relate this to the state. Even if we stay on the RP tree and you only have a star G join in the control plane, but do you use the same star G in the forwarding plane, or do you actually use SG in the forwarding plane? Star G. Just star G. Okay.
Okay, we'll add a couple of those comments. Before I sit down, can you think of anything else that we should be adding to this draft?
Go back to the.
Yeah.
conference slide, just- We have a snooping subsection under 3.4. You know, should we?
Yeah, good point. I'm not sure if we do. I think we do.
About how much of IGP snooping should go into this draft, or is this kind of layer 3-ish?
yeah, I'd vote yay because that's an issue, and we've learned some stuff along the way. It was mostly an implementation. IGP snooping, I think, was never defined, and then now I think we are now, or maybe we did later.
Is there an IETF spec on
And now there's a draft that optimizes IGMP snooping, right? So I think it's worth the discussion. I
Agreed.
don't know that there's lessons learned, but it's worth.
draft that optimizes something that's not drafted?
Well, it was
Right.
it wasn't drafted, then it sort of kind of was, and now it's optimized-ish.
Yeah, I believe there are some RFCs that discuss a bit about snooping operations, but I can't remember exactly now.
Yeah, so Thomas Eckert. So I think the lesson learned is if the IETF doesn't specify a standard approach and you work in a company with 10 products, you'll get 15 different ideas on how to do IGMP snooping.
Even at this point in time.
Probably not anymore, right? But during the time that I was working on it, there were that many different approaches. So it was very interesting. I'm not sure if it's the right way to go because interoperability between all those was very fragile.
Maybe all the vendors should get together and write an information draft saying this is how we all interoperate with IGP snooping, because they do, right? Do they?
Yeah. To the largest extent these days, but there were a lot of bugs that had to be fixed in the different implementation in the 2000s, right? So I would certainly stay very high level up to those points, right? That there are a lot of different options coming out. That's nice, but then of course, as Dino said, a standard approach should be done, and I think we're way past the time to have any impact on the industry now.
Maybe this draft should say IGMP snooping was developed through implementation, no specification. And we had pain points during those years. That would be useful.
Yeah, good
to
point.
tell people.
Yeah.
Prasad, Cisco Systems. Two or three things. 3.4 calls out IGMP, but you don't call out MLD. I don't know if the draft talks about MLD.
Yeah. You know what? Somebody pull up the draft and find out. I don't remember, but that's a good point. If
Okay.
not, we will.
Okay. Second thing, of course, same thing for MSDP. You call about MSDP, but you should probably talk about Anycast RP, the equivalent, IPv6 equivalent as well. So that's another thing.
Embedded RP.
Yeah, embedded RP. That's a good point too. Third thing, MPLS and VPNs. Should we talk about Lisp as well? Because that's the other way of doing multicast. And that's quite used. I mean, quite deployed. Up to you.
I'll ping you then, because we would need to have a lesson learned on that.
Okay.
Well, yeah,
And,
yeah, good
and,
points.
one last thing about DSPT, RPT. So there are certain use cases where there is a non-zero threshold. It's neither zero nor infinity. Certain use cases do use that. It's not that it's never used. At least I've seen deployments.
The
with
non-zero.
Yeah, they're
Yeah,
non-zero.
okay, yeah, I'm
Thank you.
sure, yeah.
Mankamna, Cisco. So just on IGMP snooping point, so RFC 4541 is the spec which really defines IGMP snooping and MLD snooping both. It is informational draft though.
Okay, thank you, perfect.
Yeah, that's what I thought.
So I think for any of the other protocols they were brought up, right? I think we need to be careful to remember this is PIM, not MBOND. So we're only interested in protocol lessons learned, not deployment lessons learned.
Yeah, good point, yep. Yeah, it's, there was a debate about protocols, as long as it's about protocols, because that was the debate where this should belong in our focus. Yeah, exactly. And I'm going to sit down now. Thank you. So,
It's me. Yeah. I'll be quick. Yeah, hi everyone. I think we're almost caught up on time, but I'll be fairly quick here, I think. So I've been presenting this many times now, and I think it's pretty much done, at least from my side. So I think you all know what this is right now, or by now, but at least this is like a new TLV format that allows us to have sub TLVs, which is quite useful if you have if you announce say an S, G and you want to associate some additional information about the flow. It can be flow rate or it can be other parameters. Like flex algo, for instance, is one thing too. We'll talk about later today. The draft also has some optimizations. So normally you flood these messages on all interfaces, but if you have but if you have multiple interfaces between two routers, it can avoid some unnecessary forwarding. So that's what the draft is about. I've also implemented the draft, and there's some more details in the draft based on the implementation, and I think it's all ready to go. So the question I have for the working group is really, what do we do next? And offers think it's ready for last call, but I don't know what you guys think.
does this update the PFM RFC?
Um, it doesn't. Maybe in a way, it kind of adds to it with a new TLV format and some stuff. You can implement the base one without implementing this if you want.
Oh, okay.
So I'm not sure if it should be an update.
But either way, it's experimental, right? Just because
Yeah.
the base is,
Yeah, the base is experimental. This is experimental.
okay. Well, we can think about the update thing.
Multiple point-to-point links between two routers. Why wouldn't you use that instead?
Well, it can be a LAN, but basically there's only two routers on the link in this case. If you have more than two routers, then you don't do the optimization.
It's more than two.
Yeah.
I'd like to know if the type of this draft can be changed to standard, because we'd like to make reference of this draft, and I always get a alert that it seems like the experiment draft will be a downstream reference. Yes.
Yeah.
So I think it can be the type of this draft can change. Yeah.
Right. So I would say we have an implementation in Cisco that has shipping using the initial draft that has been it's been shipping for more than a year now, and I think we might want to move to proposed standard at some point.
Yes, our implementation is on shipping. Yes.
Yeah. Okay. But at least my thinking is try to get get this done, and afterwards we can start thinking about, yeah, is it time to move to proposed standard? Do we have more than one implementation, or what do people think?
A real quick comment. I think the draft is great. I think we should have had it a really long time ago.
Okay.
But it makes, from an architectural point of view, really high level architectural point of view across all working groups and protocols at the network layer. This is a much more efficient way to move information through an AS or an IGP, much better than what has been abused with OSPF and IS by trying to move stuff in a multicast fashion through a domain. The problem with the IGPs, they have to store that state hop by hop.
Yeah.
And that's not terribly efficient, where here you just move data and then the people who want to store the data or do whatever they want, they can. But the fact that you can move data from one edge point to all the other edge points using this efficient mechanism is pretty good flooding mechanism. There's no checksumming, there's no loops. It's much better. So I don't know if people are motivated to undo that stuff or implement new stuff with flooding using this mechanism.
Okay, thanks. Yeah, I would say the initial motivation with this was, how do you distribute information about active sources? And my very first thought was, let's add it to the IGP. But then we figured it was better to do a separate mechanism. But right, and this is focused on announcing, active sources, but it can be used, there's TLVs that can be used for any information. Yeah. Thanks.
In the old days, we wanted IBGP to scale better, and we were thinking about using reliable multicast, but that technology wasn't advanced enough or reliable enough. But here you have the reliability on a point-to-point basis.
Yeah.
So you have reliability when these messages are sent. So does ISIS and OSPF,
Yeah.
but it's just more efficient.
Yeah. Yeah. Okay. Thanks. Yeah. Yeah. Okay.
Yeah.
Yeah.
I think the working group looks like
So-
they're in favor of starting the working group last
Yeah.
call.
Yeah, it's your decision.
Yeah, yeah.
but,
So I'll just start
looks.
the working group last call.
Hmm.
Probably next week.
Yeah.
It looks like we have 9 people that are in favor, so, and none against. So I think we're good.
Yeah.
Thanks.
All right. Okay. Thanks.
Yeah, I think we are. Tourless is up.
All right, the draft that keeps on giving.
No, the clicker's right there.
Yep, clicker. That's right. So we had a second working group last call shortly before the IETF, received excellent feedback from STIC. And so here's the update that I just posted beginning of the week. So I removed an erroneous statement that I saw. I'm trying to prep for more external reviewers by trying to emphasize on that this document consists of 2 parts. One is the wonderful historic text that we only wanted to update with the minimum necessary technical stuff, because otherwise it's great. And then all the kind of new stuff that we added in terms of explanation, why and what, and SSM and so on. So all of STIC feedback has been put in. Most of it's small. There is one really interesting thing about terminology. So clearly now specify that a host group is only relevant to ASM, right? So only in an ASM group can you call an IP multicast address a host group, because the SSM RFC just says it's not a host group, but it's just the destination address of an SSM channel. So IP multicast address superset of host groups and SSM channel destination addresses. So NITs acknowledgements and then security considerations. That was about something like IP multicast goes to a psychiatrist and he asks, tell me about your unhappy childhood. So that ended up in 6 pages of security consideration and 1 additional appendix, which I think should be very helpful, especially to all the people that have not worked with IP Multicast and are writing IP Multicast applications, and even protocol designers that could be doing a better job. So let me try to quickly rush through this because I think we're getting late on time. So we've got the network forwarding issues. In routers, the stateful stuff and so on. So that's out of scope, but of course it's a nice free marketing for, this has nothing to do with multicast. You can do stateless forwarding, use something like beer, for example. So then the senders cannot control who receives the traffic. We can use secrecy of addresses for it. We can use encryption keys and distribution to authenticated receivers like GDOI. We can do, and that's what a lot of IPTV networks are doing, filtering in the network because you cannot even trust cryptography. And then basically you do secure devices with trusted execution environments, DRM, and so on. So that prohibiting undesired receivers is a complex topic for a lot of application cryptography and so on. Sender control, receivers cannot control and limit who the senders is. Yeah, we can again apply address privacy, but ultimately SSM is our solution to that problem. And it's even better than unicast in stopping traffic at the source. If you have the right network set up, unicast traffic, you can only stop at the receiver. Packet spoofing. Who needs packet spoofing when you can simply become another valid ASM sender and the application doesn't see the difference, right? But the ASM model also makes discovery of senders that you want to start spoofing a lot easier. Then there are a lot of refinements of that. If you actually have a forwarding in the network, like snooping and so on, it becomes easier. And ultimately, there is the ongoing big challenge, which is still after 30 years been worked on, which is that really to authenticate a multicast message so that it cannot be replayed by somebody else, you either need to have public key cryptography on the sender side, which is very expensive, or you need to use one of these crazy complex algorithms that are still being updated, for example, for drones today. Address management. So we need a unique ASM group for every application instance, static allocation being used. All the wonderful dynamic management protocols we haven't been adopted. There are all these waste issues when you start to reuse groups, right? So you receive traffic that's for different application. It may even leak into the application, cause security issues and breakage. So really you need to do correct ASM group management, but there is the layer 2 to layer 3 mapping that also gets you at least into the host stuff. We've even seen important services break down. So industry recommendations do never reuse addresses that at layer 2 map to important link local scope addresses. And then you have multiple application instances. So best example, you can't distinguish OSPF between different instances. And when you plug together stuff that doesn't belong to be plugged together, routing breaks. So workaround, they actually use the OSPF password as the instance identifier. So those are kind of the core old security things that we know. So now that was that. MAC filters. So yeah, so we've got hardware filters in network in host devices, and you run out of them. So that's another resource that's unique to multicast. So that's all really the host stack stuff. No routers anywhere involved. There is another thing that I put into an appendix because it's outside the scope of this document, and I didn't want to add to the scope because we want to maintain full internet standard. And that is basically that different sockets should only receive the traffic that they have joined to. But we're not talking about application sockets. Now, IGMPv3 and MLDV2 are talking about that. There's one hidden sentence that says, a different socket, every socket should only receive what they join to. I can see that people have overlooked to implement that, but that's basically our way out there. We introduced level 2, which is, for example, for routers and other equipment that may not even use IGMP. They also need to implement that. Otherwise, they get traffic they don't want. And then there is the much more fundamental issue of the BSD socket concept, which was a great concept from all the API calls for unicast, and nobody ever looked into how well or not well it does work for multicast. So again, this is at the transport layer, so it's nothing to do with really the scope of the document, but there is no other document that are capturing this, right? So I'm referring a lot of the other useful documents like 8085 for UDP considerations, but they're not looking to the socket issue. Um, and I'm not going to go through the details there, so read it up on your own. But basically, the socket model doesn't work well for multicast applications, and people should be aware of it at some point in time. Maybe somebody wants to write a draft on how to do it better, but I'm not even sure how to exactly do that best. So that's 6 pages of new text. What do we do with that review-wise? So I was going to ask the working group chairs not to close the working group last call, but initiate reviews with int-dir, transport area dir, and sec-dir with the directorates of non-multicast groups. And quite frankly, this document would have belonged into an int working group, but of course nobody understands multicast there or cares. But at least let's have a good discussion in review, because as soon as we go to IESG, it's always hush hush and doesn't work well. So these reviews, while we still hold the pen as the working group, are I think very useful. I'm going to write this down in an email to the chairs, so because they can paste that into the review request form. And I've even looked through the directorates with the usual suspects, and 2 of them, Brian and Kyle, have already said they're happy to do that. So I think we'll pick Kyle for TSV, Brian for sec, and then we'll let the chips fall on int.
Yeah, great. Yeah, I tried to send some email to inter-area chairs and the working group, I think, a while ago. Not much
Oh
response,
yeah.
but
Multi what? Goodbye. Right.
yeah,
So I think the
yeah,
official form that they can't escape,
yeah.
which is I'm just not sure from the process side, is this an early or a late review? Gunter, process question? Before we close working group last call, right? As long as it's still in the working group, do we have to click on the early or the late review button in the directorate review form? Because the late one says it's IETF review. That sounds like, so it's still early.
So I think
Okay,
it's early,
it's click
yeah.
on the early review button. Yeah.
But yeah, it's great to do this, and I agree.
Yeah.
It's in a way, it's more an int area document. Yeah.
This is Dino. Did you resolve that IGMP issue that Phil Karn had about 1 year ago? It was a really good comment, and he described it really clearly. Do you remember that?
No,
you
I
were,
don't remember.
You were in the thread. He was trying to do an IGMP implementation from scratch in a small IoT device.
Right.
And he said that 1112 and the successor, RFC 1112 and its successor, wasn't clear about something.
Okay, give me the name again.
Phil Karn.
Karn, C-A-R-N?
Yeah, he's an old time internet guy who did all the radio stuff.
So I'll try to look it up.
Yeah.
And ping you. Okay,
It was a really good comment.
Maybe I don't just remember.
And it was something from day one, Steve Deering spec time.
Okay. Hopefully the notes remind me. Okay, cool.
So there's nothing that we need to do?
No. I mean, I'll send that email which says, please, one of your chairs, go put this into the directorate review form, and then click send, and then we'll get 3 reviews.
Yeah, I can do that.
And then basically, when we're fine with the answers to the reviews, we close the working group last call and send it to Gunter.
Okay, thanks.
Yeah, thanks.
All right, Hitoshi.
Yeah, I think we got 10 minutes spare now.
Yeah, we're good. Take your time. We're back on the schedule.
Okay, so this is a revision of multipath support for IGMP embedded proxy. So this slide I already shown several times. So this explains why we need to have the functionality of multipath support for IGMP embedded proxy. And we have 3 relevant drafts. This is, so today I just want to explain briefly about that first one, which called the static upstream interface configuration draft. And the second one is a dynamic upstream interface configuration draft. And the last one is YAM model for newly defined IGMP emergency proxy. So this draft shows a static upstream over here interface configuration, and we defined the channel-based upstream interface selection. One or multiple upstream interfaces for multicast channel system is selected from candidate upstream interfaces, and the interface selection prioritizes with SG, S-star, and the star G associations. And also we have priority configuration, and if we have the interface priority that has not identical value, then select only one interface from multiple interface. But if we have the same interface priorities, then we can use both to retrieve the multicast stream to enable robust data reception. And if there is no configuration, we can just use the default upstream interface. And this one, as I said, it's a second draft. It's a dynamic upstream interface configuration draft that mentions we need to have some extension of IGMP MLD messages, which are already defined in RFC 92-79. So last time, in the last IETF meeting, we showed that we asked you that we should merge the static configuration draft and the static signaling draft or not. And according to our authors' careful discussion, maybe we should keep them as a separate draft, as each draft has its own advantage. And for example, the static configuration draft clarifies the requirements and the benefits of Modbus IGMP emergency proxy and explains the implementation methods and the configuration methods and the policy definitions. So it includes the experiment, and also it includes the experimental results and the related implementations that is open to via GitHub. And the dynamic configuration draft, as I showed in a previous slide, it's completely different definition mentioned in the draft, which defines a protocol extension to support multipath IGMP embedded proxy. The second question is, now we have been thinking about status of the status change from informational to experimental. I'm not sure, maybe you may have some comment about this status change, because we already published the papers and also provide open source implementation that is run on top of SDN controllers. So maybe, of course, we need to revise some text to mention this is really suitable for the experimental document. So we need to revise, but it may be possible to work as an experimental document. So if you have some comment, then I'm happy to hear your opinion. So the next step is we have two to-dos. One is a default active interval for detecting an inactive upstream interface. We've not defined yet at all. So we need to carefully consider how we can detect the interface, the selected interface is inactive or not. And we also need to care the security threats from potential DOS attacks. And as I said, we may now thinking about status change from informational to experiment for the first draft. And so now we'd like to ask you to review the dynamic upstream interface configuration draft 2, so that we want to keep them as a separate document. Okay, so that's all.
So in regards to the experimental versus informational, did you mention that you have a implementation or
Yeah.
you do?
Yeah, yeah.
So I can see why you're probably wanting to lean towards experimental then. Is that why? Because yeah, because there's actual code.
But the implementation, is that the static or the dynamic?
It's just only for the static.
Okay. Yeah.
So the dynamic draft, so sorry. So the second one that mentions the dynamic upstream interface configuration. This requires a protocol extension. So definitely it should be the status as a proposed standard.
Yeah. Um, yeah, yeah. So at least personally, I'm thinking it's maybe good to keep the static and dynamic separate.
Mhm.
Um, I'm kind of leaning a bit towards informational for static, maybe because there's no protocol in a way. It can be kind of like a local decision how you implement it.
Mhm.
Um, but when you have controllers and so on, maybe it's kind of good to have sort of a kind of standard
Ah.
way of doing the static configuration.
Mhm.
So I'm kind of open to either. I think my thinking has been more informational, but I don't know, maybe experimental is good too. I'm not sure.
Mhm.
Um, I don't know if
Luis, you have
anyone
some comment?
else has
No. Okay.
comments.
So here's the course.
Um, yeah, yeah. At least I would say like typically I'm thinking if it's something that is like a just local implementation and informational is can often be done. Um, if it's something that is goes on the wire, then it's more like a protocol thing, right? And
Sure.
then
Sure.
it can be proposed standard or it can be experimental. But the experimental is kind of a low level of protocol. While informational is more, this is one way you can do it. Kind of.
Mhm.
Experimental is considered kind of risky, right? Like kind of,
Yeah, yeah.
I may not be the right word, but that seems like.
Yeah, no, no. At least in general, I would say is like um, people that deploy protocols in the networks, they might be reluctant to deploy something that is experimental because it sounds like, okay, this has not really been proven yet, or yeah, more risky. Yeah. Um, but it's really up to us,
Yeah.
how mature do we think it is, and yeah. Um, any other comments on this?
Okay. That's all.
Okay.
Do you want to go or not? Or, do you want to go now?
You want to
Okay.
swap? Yeah, yeah.
Okay, thanks. So we have a small shuffle in the presentation order. So this is about optimized use of beer in the AI data center. I'm presenting this on behalf of the co-authors. So the background is that use of multicast in the large AI data centers is getting attention. There was a side meeting in NASA IETF. It was well attended, very enthusiastic discussions there. We believe that beer is the most applicable technology there because there's no need to set up and maintain multicast trees. This is not only important for the scale and convergence reasons, but also important when you have bursty and short-lived multicast flows. When we use the beer in the AIDS, there is actually some optimizations that we could do that make it even simpler. In fact, those optimizations can apply to any other situations that has similar properties, which we will talk about. So I'll start with the most common or intuitive method to use beer in a data center. On the right side, I have a topology there. At the bottom, I have those GPUs, G1 through G4. In the middle, there are the leaf switches and then spine switches at the top. So the GPUs here are the sources or receivers, and the leaf switches are first hop router, last hop router, or BFIR, BFER, basically beer ingress router, beer egress router. And the spine switches are beer forwarding router. So typically, the application sources select the multicast group for whatever purpose, and that information is advertised probably at the application level, so that then when the receiver realizes that, oh, I need to receive this traffic, then it will send IGMP join towards the last hop router. Now, if we're using beer between the last hop router and the first hop router, now the BFER, which is the last hop router, will need to send beer overlay a joins towards the ingress routers so that ingress routers know what bit string to use. And eventually, the first hop router, which is the beer forwarding ingress router, will send the beer packets toward the egress router, and then who pops the beer header, and then send the packet to the end receiver based on the received IGMP state. So that's the typically how it is used. But in the AI data centers, most likely the sources know where the receivers are. And because of that, we can simplify the signaling significantly. We can remove the IGMP signaling. We can remove the beer or flow overlay signaling and a lot of other things. So I'll just get to that. So here we want to remove those heavy signaling that is no longer needed because the senders know the receivers. So now the sources or the receivers, they actually become the beer forwarding ingress routers and beer forwarding egress routers. They are assigned with beer or IDs. In the AIDC case, that you could even just use GPU IDs because I've seen some proposal to basically assign 16 bits IDs for the GPUs. So they match up with the BFR IDs perfectly. So now the leaf switch, which is last hop router, they can actually do the beer or penultimate hop popping. So the receiving GPUs, they don't even need to understand the beer header. And um, when the leaf switch uh, receive the beer packet, it pop the beer header. And then you will see an IP multicast header, and there it does not even matter what the IP multicast address is. We can just use a single, probably a link local IP multicast address there. And as long as the receiver is pre-join that particular group, basically by actually here by join, I don't even mean that send the IGMP join. All it needs is tell the driver that accept the multicast packet with this particular corresponding MAC address and send it up the stack. So now, if the GPU, the source GPU NIC can handle the imposition of the beer header, then nothing else is needed. Here, the source will just pick a single multicast, a common multicast group address for all the flows. It doesn't matter which flow it is, just a single multicast address. Could be 224.0.0.100, whatever. And then you just impose the beer header and send the traffic, and everything will just magically happen. So now, what if your source GPU NIC cannot handle the beer header encapsulation? Now you have to rely on the first hop router or the leaf switch to put on the beer header. In that case, we need the source to tell the first hop router that for this particular flow, these are your receivers, so that you can put on the beer header accordingly. So that's why I'm presenting this here, because we need a protocol for the source to tell the first hop router, these are the receivers, and you please put on the corresponding beer header for it. So here, let me just skip to, I'm sorry?
Can you do that in the management plane instead of the protocol plane?
Yeah, so whether it's protocol signaling or management plane, it doesn't matter. Basically, some information that tells the first hop router. Here, I'm proposing a IGP MLD extension. So today, but basically, currently we have the IGMP query and the IGMP membership report. The report is for the receivers to tell the last hop router, hey, I need to receive this traffic. Now, this we're proposing this receiver proxy report. which is used by the source to tell the first hop router, this is the list of the receivers that need to receive this traffic. So that's the extension that we're proposing here. And well, sure. Well,
It's a source signaling, right? I know it's about the receivers.
right. The name, I don't care about name. So any name is fine. Here, I call the receiver proxy report basically just because this is a proxy report from the source to tell about the first hop router of the receiver. So we can choose a better name. That's fine. So this is the basic proposed encoding here. The first two lines are just typical. First line is basically the generic IGMP message format, and the second line we have one an E bit to indicate there could be sub TLVs at the very end for extensions, and then we have bit string lengths and the number of bit strings and number of receivers. So if you don't have many receivers, all you need is just put in the receiver address in there. But if you have many of the receivers, and a more efficient encoding will be just putting the bit string there. That's why we have those. We have both there, but we only one of them, the number of bit strings or number of receivers, will be non-zero. So you use either. So that's basically the idea. So quick summary: we do not need new beer signaling or new beer procedure. The IGMP MLD receiver proxy report is needed only if the first hop router need to put on the beer header instead of having the source to put it down. But otherwise, nothing needed. So,
Marcus. So yeah, but I like that thinking. But if you do that, then you do probably want to use different group addresses, right? Because every different flow will have its own combination of destinations. So that goes against a little bit what you said initially, where you only need a single local link group address. But here you do need to separate those out, right? And
you are right. I actually skipped the detail here. So when the source cannot do the beer encapsulation, you have to rely on first hop route to do that. Indeed, we do need to use different multicast group address for different flows. And if the first hop router could change that multicast address to that common one, then great. It's very simple. But if the first hop route cannot do the change, then the receivers need to be prepared to pre-join all those possible groups.
Yes.
Yes. Yeah.
I have two questions or comments. First, high level. This is only going to work across racks, not GPUs that are across servers within a rack. Is that correct?
It can be across servers. Basically,
then you're putting the BFR stuff in the servers. True. In the host.
Yeah.
Versus top of rack.
Yeah.
Okay. Yeah. But you think the algorithm will work in a more specific, right?
I think it can work across the entire network.
So could this replace NVLink because they have the 72 servers in a rack?
That's actually I need to think about it and follow up with you.
Okay, so that's the first. The second question is: you said the source knows all the receivers. Does it know it from the mixture of experts layer, where the receivers are from, or how does the source know all the receivers?
My understanding, actually, to be honest, I only learned heard of this from other people. That's the sources would know the address, the receiver's identification. In fact, it's the sources that pick which ones will need to receive.
Okay, so what I see is if the source is saying who the receivers are,
yeah,
I see multiple control planes happening in parallel because the receivers still have to IGMP report according to what you said. Can one be eliminated versus the other?
No. when because the sources know the receivers, so the receivers actually do not need to send IGMP join anymore.
They do what?
They do not need to send IGMP join.
So how does the kernel receive the packet? Because through the socket interface, it'll.
So the I think so the kernel will pre-join the common multicast address. For example, the
Because when you
224.
send a UDP socket receive down, it sends an IGMP report out. Do you want to prevent that, or ignore IGMP reports?
Yeah, you
in the
could.
BFI,
Yeah,
or
yeah,
something. Okay.
yeah,
But just
yeah.
don't let them get intertwined.
Yes, you're
So
right.
you're saying that this new report is going to be authoritative over the receivers
Yeah.
versus the IGMP report.
Yeah. No, the receiver signaling from the receivers, and no peer flow overlay signaling. Yeah. Thanks.
Jeffrey, have you authors considered at all like having the use case draft in the beer working group potentially, and then splitting out the IGMP extension part, and just only that being a separate draft worked on in PIM? Is that something that you've considered or no?
So the homing of this draft is actually it's fluid. Obviously if we want to standardize IGMP signaling here, it needs to belong here.
So
Yes, that I have no question, no issue with that. And if we put that aside, on the beer side, there is really just no new product, no procedure, no signaling. So can be a informational draft, or we don't even need a draft. It's just a way how this could be used. So we don't even need a draft there.
Well, the
So,
use case draft maybe.
yes, yes, it could be. Yeah.
Yes, Stig here. Yes, we can, define the message is here, but yeah, the key thing is whether I think beer working group thinks it's a good solution, right?
Sure.
Yeah.
I think that can be discussed.
You're presenting beer too.
Yes.
Yeah. Okay. Perfect. Thank you. All right, Sandy. Yeah. Is this MT?
Yeah.
MT. Just give me a second.
So Sandy again. And this presentation is for multi-topology in PIM. And I present this draft on behalf of our co-author, Benchong, Stig, Jeffrey, and Human. So this is a brief introduction of this draft. We know that PIM URL use the shortest path computed by IGP or BGP to build the tree to the multicast source. But as we all know, IGP supports multi-topology and flex algorithm, and the constraint-based path can be computed, but it cannot be used by PIM directly for now. And this is the information of OSPF draft about supporting MT and FA and also SIS protocol. So the motivation of this draft is try to define PIM message extensions to provide the way to build a multicast tree through the specific topology and the constraint-based path instead of the shortest path. So let's see, this is a traditional deployment of multicast scenarios. So let's see if we have a source with two flows, different groups. So because the source is the same, so we know that the shortest path to the source will be only one. So let me see if the R6 is the receiver and the R1 is the source. So there is only one short path for the multicast flow delivery. But if we have the two multicast flows with different group, both of them will follow the shortest path, and the bandwidth on the path is not enough, there will be packet loss. So if we'd like to use multi-topology of flex algorithm here, we can split the flow in the two paths by using FA or multi-topology. So the process is the source will advertise the information about the TED. We will introduce TED later. So with a group source info TLV, and every routers in the network will receive the TLV, and the receiver also will receive it, and R6 will join the different paths by the signaling received from the source. So after the process, the two multicast flows can be delivered by two different paths. So there is no packet loss. So this is PIM extensions for MART. So we'd like to use the group source info TLV, which defined in PFM draft just introduced by C. So we add a new TED sub TLV in the TLV to for the source information announcement. So the algorithm and the multi-topology ID and also a DPID will be advertised. And also we used a new defined TED attribute for PIM join and the plume message. So it's the same as the format in group source info TED sub TLV. The algorithm, the associated algorithm multi-topology ID and DPID will be advertised through the message. So to be noticed, we define a new DPID for indicating the type of data plane. So why data plane signaling? So some people may think that this is from IGP perspective. So why we use it in PIM signaling? So we'd like to explain it here. So currently we know that we have three types of data planes, and the one is for segment routing, and the other one is for IP flex data plane, which defined in FC 9502. And also we have a new adopted draft in LSR working group, which is soft data plane. So why the software data plane is introduced here? Because the use of IP algorithm specific prefix advertisements may not always be possible, especially if the existing deployment does not allow for the lack of the reachability using the base IGP SPF algorithm 0 for this prefix. So the use of a soft data plane provides context which still allows FlexAgo to be deployed in such cases. So after that, we know that the FA participation requires a data plane context. So which data plane will be used by PIM, we must indicate it in the signaling. But we can also don't use it, because if we only want to use soft plane data plane for PIM, we can just make it as default behavior, and we need not signaling it in signaling it in the draft. But we think that we can also use the function in the IP flex data plane. Exists at least for now. So we think that the FA number, the FA number and the multi topology number and also the DP number is required by the signaling. Yeah. So this is the updates of this version. So we add a restriction. It means that we can't advertise the TED exceed the IGP domain, because we know that they may have different meanings in other IGP domains. So this is a restriction. And we modify the example with the same address, the source address, because it's more easy to understand. So this method also applies to tests transmitted by specific traffic such as MVPN and EVPN, but the specific extensions are not defined in this draft. We may have some other draft in the associated working group. Yeah. So so that's all. So we welcome comments and review, and as the co-author, we'd like to request the working group adoption. Yeah. So any questions? So, Glenn, do you have any questions? Yeah.
Yeah, hi, can you hear me? Can you hear me?
Yeah, I can hear you. Yeah.
Okay. Yeah, I was wondering, with this is an interesting draft. So this new concept that uses the soft flex algo draft, I started reading that a little bit, which seems interesting. Um, but what I was trying to see is, let's say if you using the regular flex algo versus the soft flex algo, I was trying to understand what exactly what's the difference and what was the need for the soft flex algo. I mean, what is that providing? I guess as opposed to let's say a normal fat in participation, and how does that relate to multicast? And why can't multicast use just let's say the standard fat, and participate in a regular fat and what, so I'm just trying to understand that, and the need for the soft flex out. Thank you.
So may I have a question again?
Yeah, sorry, it was a little confusing. So the question is, when you're using, for multicast, because this is for the multicast distribution tree that requires latency, um, you are you're using this new soft flex algo draft. So I was trying to understand why can't multicast work with the existing flex algo, RC, the existing flex algo, and why the need for the soft flex algo?
In my opinion, there are two perspectives here, and because one is that PIM must get the route calculated by IDP, and the other one is that the FA flex ego algorithm is defined in IDP, right? So every router advertises the flex ego participation by IDP extension. So Peter.
It's Peter from Cisco. Hi again, it's Peter here. Just a clarification for you. You have to pick one data plane that FlexAlgo supports because FlexAlgo needs the data plane participation. That's how it builds the topology. Now, the reason why you may want to think about using this soft data plane for multicast is that you may have a network where none of the existing data planes that FlexAlgo runs over is available. So we wanted to give you something which is not SRv6 or SRMPLS or none of these, which you may say, well, I don't have that in my network. How can I use the FlexAlgo pass? So we come up with some virtual data plane, which is not a physical data plane that you can actually use to accomplish what you need for multicast. Does that answer your question?
Yes, completely. Thank you so much. Thanks, Peter. that explains it very well. Thank you so much.
All right, thanks.
All right, so we had some support and some opposed to adoption, but we'll ask the list and we'll go from there. We'll adoption call.
So it will in adoption list, right? Yeah.
We'll look for it on the list. Does that make sense? Yeah.
Yeah. Thank you.
And then maybe you, Gian, if you can mute, that would be great. We're hearing something in the background.
Oh, sorry about that.
Yes.
Thank you. Yep. Prasad.
Good evening, everyone.
one is it? Oh, this is it. Yeah. Yeah, now you can do it.
Okay. So yeah, this was presented last time in Madrid and oh, okay. So this was presented last time in Madrid, and I'm trying to just give an update of the draft again, just to take it forward. Most of the work is based on informational RFCs or experimental RFCs. I'm sorry for the typo. They are both right now um, experimental RFCs. And why did they? I mean, why were they needed? Uh, you know, uh, Basically, the idea is to essentially have TLVs that tell the upstream guys on how the Lisp encapsulation needs to happen. For example, this is based on Lisp, and if there are ETRs, basically egress tunnel routers, then the egress tunnel routers, in addition to expressing their interest to join the overlay multicast stream, they also specify the underlay multicast properties. For example, whether they need IPv6 multicast, IPv6 unicast, and if so, which addresses to be used in the underlay, that kind of information. Um, and again, why is this needed? Or rather, specifically for Lisp, the encapsulation properties can vary, especially if you have a mixed deployment. Like, for example, some of the Lisp sites are capable of receiving only unicast traffic, whereas some of the Lisp sites are capable of receiving unicast and multicast, but they have a preference one way or the other. Same for the address families, and therefore this is definitely needed. Um, Good amount of implementation has happened, both for the V4 and the V6 underlay, and both for unicast and multicast, and therefore we think that it's no longer need to be experimental. Plus the 6831 work, which is essentially the main Lisp multicast work, is also now becoming standards track, and this is one of the very what should I say, very, very important building blocks for the 6831 to really, go to full standards track. So that's why we think that this is definitely a good candidate to go to standards track. Yeah, so in terms of the details, I think two attributes are defined. One is what we call the transport attribute, as I covered earlier. Whether we need it as unicast or multicast, the egress router can essentially, the ETR can signal the ITR whether it needs it in the unicast encapsulation or the multicast encapsulation, the address family, and then the attributes primarily being the group address or the RLOC, in the Lisp terminology, the RLOC address. And of course, it caters to all the known underlays that we currently use, and supports mixed mode. Um, I think the IANA code points, Dino, correct me if I'm wrong, I think the existing code points should be fine. We can probably request the same code points to be allocated, so shouldn't require any new code points. Yeah. I'm sorry about the last statement as well. Original documents were in PIM, so I think we probably have put this in PIM. But both Lisp and PIM working groups will be requested for feedback.
But the RCs you're updating were done here.
Yes. 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 Yes.
Okay.
Thank you. Thank you.
Thank you. Do you have any comments or anything?
No.
No. All right.
Offered.
Oh, okay. I forgot. Okay. Then you really can't do much. All right. So then, since you are an author, is there anything that you're asking of us to do right now as a working group, or as me as a chair?
I think if the documents, I mean, we see the documents reasonably stable, so should be definitely good candidates for adoption.
Okay. So I'll ask a list.
Sure,
yeah,
sure.
Take a list.
The only point to note though is, they were done as two different RFCs. Now we're just merging into one. So most of the content remains unchanged, at least as far as I know, other than minor editorial changes, which kind of required to keep the same flow. I've not really changed the technical content of the draft, but if there is anything that I missed out, happy to be listening to the feedback and incorporating.
Okay.
Thank you.
Thank you. All right, and then lastly, I think lastly, Mankamana. Yep.
Good afternoon. I think we are on time.
Yeah, we're doing great. We
Okay.
got 20
So,
minutes.
so even though the subject says multicast over SRv6 network, in reality, the solution which we are going to present is true for SRv6 underlay or IPv6 as well. So it is not really restricted only for SRv6. What we are trying to achieve is, so PIM has been a protocol which operators and vendors both have been knowing it for last many decades or 2 decades at least. And if we want to see that if the newer network, if you are upgrading your backbone to IPv6, what will you do with multicast? And there are a bunch of use cases which needs to be solved. This draft is informational as of now, but after adoption, if some cases arises where we really need to make some extension to protocol, it may change. But for now, it is informational. So what we are trying to achieve is how exactly you are going to deliver multicast traffic if your backbone has either V6 core or SRv6 core. So we will start with the very basic use cases where you may have end to end, which is IPv6. So if your host to receivers are IPv6, nothing prevents us turning on just PIMv6 and things will work as the way it is working today. So there is no change needed. The only few things which this draft defines is how exactly you are going to support if your source is IPv4 and backbone is V6. So today for overlay notification, BGP has RFC 5549, which defines in IPVPN that how exactly you can carry your V4 prefixes over V6 backbone. And so this draft also talks about how exactly we are going to handle the multicast in context of 5549. The other use case which comes is you may have your network, you may have your network with FlexAlgo. The last draft we were talking about how exactly you're going to build PIM tree using FlexAlgo. So with V6, that also applies. So in that case, you can have your PIM tree built just within the FlexAlgo based on your affinity, or you want to have a low delay tree, or any of the constraint which you are defining. So this draft doesn't define anything as such. It is going to reuse the previous draft which was defined. And we had there are use cases or there are operators where they may be more comfortable that if controller itself takes care of replication point to be provisioned. So instead of PIM running in the core, you may want to have maybe more traffic engineered path, and you want to really take decisions centrally. So in that case, there is a way where your controller can directly program the replication points. So if you look from the forwarding point of view, forwarding, it is still native multicast forwarding. The only difference is who is programming those forwarding entries. So in case of PIM, you have hop by hop protocol, which is distributed protocol, is going to go and program your replication points. In case of controller, you have controller who is talking to replication point and directly programming the replication nodes. The last case which it talks about is how exactly we are going to support multicast over VPN. So if we really look at it, it is exactly as the first case which we spoke. If your source is V4 and your core is V6, how exactly we are going to carry our traffic? So in that case, some kind of tunneling mechanism is required. Same mechanism will be used for multicast VPN as well. So in case of multicast VPN, again, we rely on 5549 to deliver or to distribute your reachability information using 5549. Your source could be V4 or V6, and the data plane will be built or underlay tree will be built using PIM V6. When it comes to data plane, your encapsulation, I think it's very small. Okay. So the way in the data plane it will look like, if I look at my packet at ingress, I get C IPv4 header, RV6 header with payload, And all I'm going to do is I'm going to use provider v6 header on top and ship the packet as a native multicast, and other side will just decap it. So this is the solution. Last time I did present it. Last 3 months we did try to talk to some of the operators as well about how exactly they feel about this solution, and we see that there is enough interest. So I would like to go for adoption call for this draft. And if there is any question.
Sorry, Thomas Eckert. Why is this not being proposed to MBOND? Are there any new protocol things?
I can present to MBOND as well, so that is not a problem.
Yeah, I mean, this looks like all deployment choices of how to shuffle, mix, and match and make people who love IPv6 happy, right? So, well, I mean, we have people. I mean, that's the operator split we have, right? MPLS or IPv6, right? So those are the two.
So
I think it's perfectly fine to, have documents that are focusing and doing that, even if there is some overlap, right? Unless we find not even sure if all the options you ever want, even for all the network options you're not interested in, right? So if somebody is not interested in MPLS or v6, I'm sure they'd rather like to read MPLS only or a v6 only, options guide.
Yeah, so I think last time this question did come, and answer remains still same, that this draft really talks about if you want to use PIM v6. So it doesn't prevent you using anything else. So if you want to use PIM v6, how exactly you are going to do that? That is what this document talks about. Yeah, Nils.
Right, Niels from DT. Marco Manau, we've exchanged some thoughts about the different options, and I really appreciate that there is further request to the community to share and request thoughts from other operators as well. Because if you are like us and you are in the midst of the deployment planning towards SRv6 on the core, you from at some point you stumble across the question, what are you going to do with multicast? So in order to sort that out and to really evaluate for each network the different options there, I find this really helpful, and I would really like to see other operators raising their voice and getting into discussions around that.
Thank you.
Did you have something to say, Lenny?
Yeah.
Oh, you're just looking something up.
No, I didn't enter the queue.
Oh, just go. Yeah, you're fine.
Sorry.
You have to pay to comment without going into queue.
I couldn't click fast enough. So Lenny Giuliano, HPE, Juniper, and MBOND co-chair. So there is a draft in MBOND that sounds vaguely familiar. It's non-source routed multicast and source routed networks. Is there overlap, or they sound a little similar? Are you aware of that work? And
I haven't looked at that, so I think I'll have to take a look.
Jeffrey Leaf, he's a co-author of both. Be curious if there's overlap there.
I can take a look.
Yeah, there is some overlap, but even both together don't cover all the options we have, right? So it's maybe divide and conquer in multiple drafts that people are willing to contribute work to, right? Ultimately, we've got the experiences guy draft who's open to everything. And how many years are you going to continue that draft? So, I mean, scoping things may actually help, right? Even if we have to acknowledge there are overlaps and we point to the other drafts and maybe we try to minimize them. I don't know.
Sure. That's all.
Okay. So you're requesting
adoption call.
Adoption.
Yes.
Okay, let me just do a quick poll right now. And we'll take it to the list, but let's just see initially
Sure.
what people think. And I think this is the last draft, right? So I think we're good. Yeah. Thanks.
You're free.
Yeah. Not too bad, actually.
Yeah. Maybe it was good.
Yeah. Yeah, exactly. Yeah, maybe so.
Otherwise, we would be free too.
Yeah, that's true. So yeah, you're good. Well,
thank you.
I'll just tally this. Thank you. And then we'll ask on the list as well. Anything else? We're good. Thank you, everybody. We're done. These show of hands polls are kept somewhere, right? I think they're saved, so I can look at them. Yeah. Okay. Okay.